Our first speaker is John Vickers. John is a principal technologist in advanced manufacturing at NASA Marshall Space Flight Center, and we'll be talking on in-space manufacturing. So John, take it away.
Hey, thanks a lot, Mike. I'll see if I can get my camera adjusted. If I don't like it, I might cut it off through that's distracting me too much. I appreciate the opportunity. I either wasn't given much guidance in what I should talk about today, or I totally ignored the guidance. So I went off on my own a little bit, and I hope I say one or two things during the day. I do know we've just got 10 minutes, so I'll talk fast, which is a little bit unusual for me as well, and I'll do my best. But let me say again, thanks for having me today. I'm glad to hear some of the other presentations that I've heard today and this week, and glad to get to talk about in-space manufacturing. I'm going to throw in some other topics, material science, and so those are some of my most favorite topics. And maybe just one opening remark and observation that something that I've been hearing today is how we don't do this alone, how we partner with industry and academia and others, to bring people and expertise and their capabilities, new ideas to the table to help us in this business of space exploration to be more innovative and successful. Like I said, I'm sort of talking from my own perspective today. I want to make a point, and in this whole 10 minutes that I have, I'm going to make an argument. Really, as you see on my, let's go to the next slide, I guess. Go ahead, please. In this whole 10 minutes that I have, I want to make an argument for the industrialization of space, and that's sort of going to be the focus, along with linking science, technology, and commerce to enable that industrialization. So good luck with all of that, right, in 10 minutes. So, hey, Mike, I want to make sure y'all are hearing me, I guess. It's hard to know with no feedback.
You're fine.
Thanks. All right, so about the title on this slide, where I've said the fifth industrial revolution, I've been talking about that for a couple of years in conferences and other presentations lately. So to set the stage for that, we're really just currently we're early in the fourth industrial revolution today, which is about the digital transformation. It's going to be very transformative and very far-reaching. I do a good bit of work in that area because my area is advanced manufacturing. I mostly work in the digital twin approach, which is only part of the digital transformation, but I speak on that quite a bit. So that gives me some experience, I guess, with industrial revolutions per se. They're really very generational. There's only been 3 so far, and they're a big jump forward in technology. So if you go out and on a limb and make the prediction of the next one or another one, it's a bit of a gamble, and I'll give you an example of that. But it really is my belief that in-space manufacturing, together with the overall expanding space economy, will be the subject of the next or the fifth industrial revolution. And there's an awful lot of drivers for that, and it's a big topic, so I'll just get to a couple of them today relative to this audience. Like I said, so I'm really focused on this industrialization of space today. And for me, microgravity material science and in-space manufacturing, and I use those terms in the broadest sense, are a means to that end. Though at the same time, I am really excited by the science projects and the technology projects for in-space manufacturing technology, because that's my area. So I get really geeked out on that. Now, by the way, if you research, as I do, manufacturing in space or industrialization of space, you'll go back and find a journal article from about 1979 by that same title, Industrialization of Space, and I can give you that reference if you're interested. But among other things, they describe how microgravity materials and processes would produce impacts to world trade, and they actually predict in that article that industrialization of space would be the third industrial revolution, and they predict that in just a few decades. And obviously, they overestimated the speed at which that would occur. Now, there's also a book from 1975 called The Third Industrial Revolution. You can get that on Amazon for just a used copy for just a couple of bucks, by the way. And it goes into a lot of detail about how space material science research and manufacturing, and it also predicts this same third industrial revolution. It goes on to predict about $2 billion worth of commercial markets in the 1980s from in-space manufacturing. And so obviously they missed those predictions by a few decades as well. And so you could ask, what's different today? And so I'm going to try to make a little argument about that. And I believe it's the commercial stimulus. We're all hearing about commercial space today. There's all kinds of variations of that. But I believe there's this natural confluence between material science, manufacturing, and commerce in space that will provide this integrated approach for more capable, more affordable, for NASA, more reliable missions, and at the same time, expand commercial space markets. So a little bit about NASA now. Although not as fast as I would personally like, I think long duration space missions are already adopting in-space manufacturing as a shift in space architectures to provide more resilient and Earth independent missions through things like on-demand fabrication, repair, recycling, and recycling capabilities for critical systems, logistics, and maintenance. And some of the folks on this call are working in that very area today. And in the long term, in my opinion, I think in-space manufacturing will provide resources, goods, and services, just as we do on Earth, as a routine from space, as a routine element of economic activity. I do think there's another driver, and I won't get to talk about it today, but that's national security. And we're working with, in fact, the Space Force today and having discussions about that. I think it'll be a disruptive factor for them, for their U.S. presence in space, but that's out of my swim lane. So that's all I'll say about that today. So back to the chart. When I say in-space manufacturing technologies are evolving rapidly, and somebody called me at this right now. Let's see. Are evolving rapidly and bit by bit for the sustainable path to Mars. What I really mean is, I think today we have in the constraints that we have a very robust portfolio of demonstrations currently, and for what we have planned. And then when I say bit by bit, I don't take that as slow. I don't mean slow, but I think as a steady, step-by-step approach. And that's what the graphic on the chart is meant to, the pictures on the chart are meant to illustrate.
Hey, John, you got about 2 minutes?
You got to be kidding. Let me see where I can go forward on this. When we launched the first 3D printer together with Made in Space in 2014, I think that's when things changed. And you see a photo of Butch Wilmore there, our most iconic photo really for that. Not that we hadn't pursued in-space manufacturing before, but this was a revelation that made known to all of us that much, much more was possible. And we're still pursuing projects aboard the ISS as a demonstration platform, and that's an ideal demonstration platform. But what I really believe is one of our top priorities should be that similar kind of capability on the lunar surface for us to do those same kinds of things. I think y'all already heard, if you were listening from Corky, about the plans for 3D printing construction. So I won't talk about that. But I don't know if we heard about the new NASA CHAPEA Crew Health Performance and Exploration Analog, where they have they've built this 3D, or building this 3D printed habitat to resemble an experience of living on a future Mars habitat. And we plan to have a 3D printer in that hab as well to do experiments and demonstrations. You know, I know I'm running out of time, and I didn't make my argument very well, but I really think that this quote, passed as prologue from Vannevar Bush after World War II, where supports my argument for this linkage of science, technology, and commerce, where he says a nation which depends on others for its new scientific knowledge will be slow in its industrial progress. And so that's the whole point that I was trying to make for us today, is this linkage between science and technology, commerce, and thanks. I'll give you back whatever time that I had, Mike.
Hey, thank you. Thank you, John.